All right, so jumping into constant velocity problems, I'm going to be really quick here. This here, if an object has an initial position vector A and moves with constant velocity of vector B, its position at time t is given by this formula. Now, this should look exactly like our equation for our line from a previous section we've done, and it is. If we get ourselves onto this line, realistically, if the velocity is acting in a certain way, once we get to our fixed position, the velocity will just move us along that line in the direction we want. And our basic examples, we start with a velocity in a straight line. Now, our vector B is our velocity. It gives us our direction. The length of those components is going to be what our speed is. It doesn't have the direction anymore. It puts all the components together. So let's jump into an example really quickly. So we've got this vector here, x and y equals the vector 1 and 9 plus t, 3 and negative 4 is the vector equation of the path of the object. T time is in seconds, it's greater than 0, and the distance is in meters. So what this means here is we're looking at t here is in seconds. And so realistically, every time we multiply this t, we're going to be doing so I'm jumping a bit around here. This is my velocity realistically, because in the x direction, every time t goes, I'm going to move by 3 meters. And in the y direction, it's going to be t times negative 4, which means I'm going to be moving still 4 meters every second, but I'm going to be moving down. So these here are the individual components. So we're moving 3 in the x every second, and we're moving 4 in the y every second. But let's start doing this question. So find the object's initial position. So just like in a lot of our topics, initial position t equals 0. Initial position. So therefore, we're going to have, x and y will equal 1 and 9. Oh, that's a G. And 9. Now, you can imagine if we actually use the sort of spec notation here, that actually almost is easier. It's almost like a coordinate here, but I guess that's one of the issues with it is you're looking at this could possibly be an issue here. Now, it says plot the path of this. So obviously, originally we're at x equals 1 and 9, so we can plot this particular one. I'm wondering whether I've got enough squares here. I probably don't. Let's just, I'm just going to get rid of this for the minute, and we might find room for it in a sec. So if we draw our axes here, we've got this isn't like our methods course where we're looking at t being a variable. We're looking at x and y are our positions, and then we're looking at putting our t's on here. So at 0, t equals 0, we've got 1, and then 1, 2, 3, 4, 5. Let's put a 5 there. 6, 7, 8, 9. So that means this position here is 1 and 9, and this happens at t equals 0. That's our initial point here. Now, it says plot our initial path for t equals 0, t equals 1, 2, and 3. Now, it's up to us how we do this. Realistically, we could just put this in our graphics calculator and keep calculating, or I could actually just go, well, I'm going to go down 4 units in my first second, and then, so 4 units down, 3 units across. So 1, 2, 3, 4, and then 1, 2, 3. This will be my next spot here. So, did I get that right? 1, 2, 3, 4, 1, 2, 3. So this here is going to be t equals 2. And we could either calculate it, but it's going to pretty much be here. If we were looking at this vector, we can almost think about this. 1 plus 3, it's going to be at 4. 9 minus 4, it's going to be 5. So this should be at 4 and 5, which perfect it is. So we've got 4 and 5. And then my next step here, let's just keep going straight. Oh. Now, I'm just sort of eyeballing this because I'm going to go 1. Actually, no, let's do it the way I did the last one. I liked that. So 1, 2, 3, 4, and then 1, 2, 3. Perfect. This is my next one at t equals 3. And this, I can already see here, is going to be 1, 4. So 1 to 4 is plus 3. And then this one's going to be 7. And 9 minus 5. 9 minus 4 gets me to 5. Minus 4 gets me to 1. So 7 and 1. Perfect. So t equals 3. And then last one here. 2, 3, 4. 1, 2, 3. I'm down here. And this one here is t equals 4. And it will be at 7 minus... 7 plus 3 is 10. And it'll be 1 minus 4, which will be negative 3. Okay, so find the velocity vector of the function. That is this, no, that's not that one. It's this pink one that I've highlighted up there. So the velocity vector is B, I guess we're using in this particular one. So B represents the velocity of the function, or constant velocity, the velocity vector. And in this particular case, it is 3 and negative 4. 3 and negative 4. And let's just highlight that so we can see we got it from above here. Find the object's speed. Let's just move this a little bit over so it looks like it's in its own spot. Okay. Just going to write here is velocity vector, so it looks like I've stated my answer. Find the object's speed. So our definition for the speed is we get the velocity vector, we take the absolute value, so square root 3 squared plus negative 4 squared, which is going to equal square root 25, and it's going to be in meters per second, which is going to be 5 meters per second. Cool. If the object continues in the same direction but increases its speed to 30 meters per second, state its new velocity vector. So let B2 be new velocity vector. B2 is going to equal 1 over... Now, I'm just going to put a 1 there. Remember, this one here is 1. This one here is 1. Do we have it labelled anywhere else? No. So 1 over B1 times by B1. I'm going to move this out a little bit. So let's change colour. So this here, what this calculation is, this is giving me, oh, that's not what we want. Let's change. This bit here is giving me the unit vector of B1, and then we're going to times that by 30, which we'll highlight with maybe a bright yellow. So that means the next step here, we're going to have B2 is going to be 30 over, we've already calculated this B1 here, which is 5 meters per second. So 30 over 5, and then times by our velocity vector, which is 3 and negative 4, which means it's going to end up being 6 times 3, negative 4, equals 6 times 3 is 18. 6 times negative 4 is negative 24. Therefore, new velocity vector is 18 in the x direction, negative 24 in the y direction. And that's it. All right, great work, guys.